Okay, so in the last lecture, we have solved some problems based on the partial differentiation. Now we'll try some more examples. Okay, so let us see. Okay, so I hope you are able to see this example. So we have if u is equal to 1 minus 2xy plus y square, this whole bracket raised to minus half, then we have to prove that x w by w x minus y w by w y is equal to y square u cube. Okay, that's what we want to prove. Now see what we have to do here exactly. Okay, so how to solve this problem? Okay, so what we have to do is we have to find the derivative of u with respect to x, then multiplied by x, and this will be your equation 1. Okay. Now the next what we have to do is find the derivative of this u with respect to y, then multiplied by y, and this will be your equation 2. And now what we have to do next is subtract equation 2 from equation 1. Okay, and this is how we are able to get the solution. Okay, so let us try to have the solution. So we'll follow this step, and then we are able to get the solution. Okay, so let's calculate the solution. Okay, so what is given, always start with the given thing. Let u is equal to 1 minus 2xy plus y square bracket raised to minus half, and be the given function. Okay, that's what we have. Now as we can see what we have to do exactly. So what we'll do is differentiating u with respect to x partially, we get. So what we are able to get here, see, w by w x is equal to w by w x of 1 minus 2xy plus y square bracket raised to minus half. Now, as we know, the derivative of x raised to n is equal to n into x raised to n minus 1. So what we'll be having here, this minus half will come down, and you will be having 1 minus 2xy plus y square minus half minus 1. Now we'll have the derivative of this bracket. So 1 minus 2xy plus y square. Are you getting this term?
Yes, sir.
Okay.
Yes, sir.
Good. Okay. So this is equal to what we get here. This is minus half 1 minus 2xy plus y square bracket raised to 3 by 2, minus half and minus 1. And now here the derivative of this one is going to be 0 because we are differentiating with respect to x. Here 2 and y is going to be constant, so the derivative is going to be 2y, and the derivative of this term is again going to be 0. So this minus 2 and minus half will get cancelled, and then we can write y into 1 minus 2xy plus y square bracket raised to minus 3 by 2. So this we can write as y into 1 minus 2xy plus y square bracket raised to minus half raised to 3, and we write it like this.
Yes, sir.
Okay, but you can see this term is exactly u. Okay, so this becomes y into u cube. Okay, this becomes y into u. Okay, and hence what we can write here, we are finding the derivative of this u with respect to x. So we can have w by w x is equal to y into u. Now what we see here, the first step is completed. We have got the derivative of u with respect to x. Now we have to multiply it by x. Okay, so what we have to do here, hence multiplying above equation by x, we get. So what we are able to get, x w by w x is equal to x y u cube, and this is the equation. Okay, so we got here equation 1. So you can see this is what is expected, equation 1. Now we have to find equation 2. So what we have to do first, we have to differentiate the given function u with respect to y, and then we have to multiply it by y. Okay, so let us try to find equation 2. Okay, so what we can do is differentiating u with respect to y partially, we get. So what we are able to get is w by w y. So it is w by w y 1 minus 2xy plus y square bracket raised to minus half. Okay, this is the function. So what we can have, again, this minus half will come down, and you'll be having 1 minus 2xy plus y square minus half minus 1, and you'll be having w by w y of 1 minus 2xy plus y square, the derivative of this bracket. So what we are able to get here, this is minus half 1 minus 2xy plus y square bracket raised to minus 3 by 2. Now here the derivative of this term is going to be 0. The derivative of 1 is going to be 0 with respect to y. Here 2x is treated as a constant, and the derivative of y is going to be 1. Plus here we have the derivative of y square is 2y. Okay, so we are in partial derivatives, so we have to be careful. Okay, so we got here the derivative. Now let us simplify. So what we'll be having here is going to be minus half. It's going to be minus 2x plus 2y. And then we will be having 1 minus 2xy plus y square bracket raised to 3 by 2. Or this is, I can cancel this minus half and I can take this 2 out. So I'll be having minus half minus 2 x minus y. And here we have 1 minus 2xy plus y square raised to minus half, and this bracket is 2. So this minus 2 and minus half will get cancelled, and so you'll be having x minus y, and this term is going to be u cube again. So we got w by w y is equal to x minus y, and this is u. Now see, what we will have to do is we have to multiply this by y. Again, so let us multiply the term that we have obtained by y, and hence we can write here multiplying of equation by y. So if we multiply this by y, what we are able to get is we get y w by w y is equal to y x minus y and u. So we can write this as x y u cube minus y square u cube. Okay, and I consider this as equation 2. So this is what we wanted, equation 2. You can see here. So what we want, we have to find the derivative of u with respect to y, then multiply it by y, and this becomes our equation 2. Okay, so we have obtained equation 1, we have obtained equation 2, and hence we can write here. So y w by w y is equal to x y u minus y square u cube. This is going to be equation 2. Okay, so we can write here hence from equation 1 and we have. So what we want? We want x w by w x minus y w by w y. Okay. So we want x w by w x minus y w by w y. And this is going to be x y u cube minus, so we're having x y u cube minus y square u cube. Okay, so that's what this is, the equation 1 and this is equation 2. So simplify x y u cube minus x y u cube, minus minus will become plus y square u cube. So this term and this term will get cancelled. What we have is y square u cube. So we got here x w by w x minus y w by w y is equal to y square u cube. And we can see that is what exactly we wanted to have. Okay, so this is exactly the term that we what we wanted to have. Okay, so this is the claim that we wanted to prove, and we proved it. So always try to derive the claim. Okay, do not try to find or do not try to track. Okay, if you will solve step by step, definitely you are going to get the correct answer. And in this case, we got the correct answer here. Okay, so that's what we have. Okay, so do you have any doubt this question?
No, sir.
No, sir.
No,
No,
sir.
sir.
Okay, okay. So all of you got this idea?
Yes, sir.
Yes.
Okay, that's great. Okay. So now, once you got this idea, you're able to find the solution properly. Okay. We can think of next. Okay. So let us try to think of next. Okay. Now we have to think what happens to the chain rule, or how we are able to use the chain rule in partial derivatives. Okay, so suppose we have the function which is a function of another variables. Okay, then we have to think how we are able to get the derivatives. Okay, so for that we need to understand the variable trees. Okay, so how the variables are related, and then how we are able to get the derivatives. Okay, so for example, okay, suppose we have a function, so where let we have a function use phi. Okay, so phi is a function of u and v, and u is a function of x and y, and v is also function of x and y. Okay. So you can say where u is a function of x and y, and v is also function of x and y. Okay. So So v is a function of x and y. So what we can have here, see the variable tree. So we have u, we have to consider phi. Okay. So we know phi, it is a function of u and v, and this u is again function of x and y, and this v is again function of x and y. Now, if I remove this u and v, so suppose we put the value of u here and we put the value of v here, then phi becomes function of x. Okay, so anyway, phi is a function of more than one variable in terms of u and v also, and in terms of x and y also. So if it is a function of more than one variable, then we have to find the derivative, and these all derivatives are going to be partial derivative. Okay, so here I'll be having dabba phi by dabba u. Okay, what I'll have dabba phi by dabba u. If I consider phi as a function of u and v, so I'll be having here dabba phi by dabba v. So if you consider now u, okay, so what we have in terms of u, u is a function of x and y. So if I consider the derivative of u, then it will be dabba u by dabba x, and this will be dabba u by dabba y. Now, if we think of this v, v is also a function of x and y, and hence, if I consider the derivative of u, v with respect to x, then it is going to be a partial derivative because v is a function of more than one variable. And if we consider the derivative of this v with respect to y, then we have to consider again the derivative, which is going to be a partial derivative of v with respect to. Now think of phi in terms of x and y. So if I want to find the derivative of this phi with respect to x, then I have to consider this branch and I have to consider this branch. Okay, so I have to consider both the branches, one which is from x, the u, and the other which is from v, and then I have to add this both the branches. Okay, so this way we'll have the formula as solving, hence we have, okay, dabba v, dabba phi here. So phi we are considering the function of u and v and x and y. So dabba phi by dabba x is equal to, for this branch we'll be having dabba phi by dabba u, dabba phi by dabba u, and this is dabba u by dabba x. So this is the branch. Now for this branch, what we'll be having, dabba phi by dabba v, dabba phi by dabba v, and dabba v by dabba x. Okay, so this way, if we want to find the derivative of phi with respect to x and y, then we are able to find it like this. Now, if we want to find the derivative with respect to y for this phi, then I'll be having dabba phi by dabba y is equal to dabba phi by dabba u. And this is dabba u by dabba y plus we'll be having dabba phi by dabba v. This will be dabba v by dabba y. So this way we are able to find the derivative of this phi with respect to x and derivative of this given function phi with respect to y. Okay, now this is in case of the function is the function of two variable. Okay, so if it is a function of three variables, okay, so what we can have, we'll be having let phi be the function of u, v, and w, and u is a function of x, y, z, v is a function of x, y, z. So v is a function of x, y, z, and w is also function of x, y, and z. Now see here how we are able to see the tree. Okay, so what we will be having here? This is phi. Phi is a function of u, v, and w. So it is u, v, and w. Now this u is a function of x, y, and z. This v is a function of x, y, and z. And w is also function of x, y, and z. Now the derivative of this phi with respect to u, the derivative of this phi with respect to v, and the derivative of this phi with respect to w are going to be the partial derivative, as phi is a function of more than one variable. Now, if we think of in terms of x, y, z, and u, then again these derivatives are partial derivatives. So w by wx, w by wy, w by wz. So here again w by wx, w by wy, w by wz. So here w by wx, w by wy, and w by w. Okay, so this way we are able to get the first order partial derivatives of this function. Now we want the derivative of this phi with respect to x, y, z. So if we put here u in terms of x, y, z, v in terms of x, y, z, and w in terms of x, y, z, then our final expression will be in terms of x, y, and z. Now, if we want to have the formula to differentiate phi with respect to x, y, and z, then what we can have is, hence, we have, so we got here double phi by double x is equal to double phi by double u by double x, double phi by double b, double phi by double b, and double b by double x, plus double phi by double w. And this is double w by double x. So this is going to be the first order partial derivative of phi with respect to x. Now, let us try to find the derivative of this phi with respect to y. Okay, so we got here the derivative with respect to x. Now let us try to have the derivative with respect to y. So we can have double phi by double y is equal to double phi by double w, double w. Okay, so we can have double w by double y plus double phi by double y. Here we got w term. Okay, so we can have this for u and v also. Okay, so we'll write this one by one. Okay. So double phi by w by y, Dabba phi by dabba v and dabba v by dabba y plus dabba phi by dabba w, and this is dabba w. So this is the derivative of phi with respect to y. Now we can think the derivative of this phi with respect to z. Okay, so and we can have dabba phi by dabba z. So it is dabba phi by dabba u by dabba z plus dabba phi by dabba v, and this is dabba v by dabba z here. And so this is going to be dabba z plus dabba phi by dabba w. And this is dabba w dabba. And so this way we are able to get the formulae by knowing the variable tree and using the chain rule. Okay, so here we have more than one variable, so that's why we have to use the partial derivatives. Here also we have more than one variable case, and hence we have to use the partial derivatives. So have you got this variable trees?
Yes.
Yes, sir.
Yes, sir, we
sir.
got
Yes,
it.
sir.
So here what we did is we have extended the idea of chain rule. Okay, so we have chain rule. When we use chain rule, if y is a function of t and t is a function of x, okay, then we use the chain rule in simple way, in one variable case. But here you have more than one variable. Okay, so when you have more than one variable case, at that time you are able to use the chain rule. But to understand the chain rule, what we have to do, we first have to understand what is the variable tree. Okay, or what are the chains that we have to take care. Okay, and once you understand the variable tree, once you understand the chains in the variable tree that we have to use for particular variable, then definitely you are able to write the formula. So once you are able to write down the formula, then we are able to solve the problem. So just go through this two types of variable tree and then whatever the formula we have written. If you have any doubt, we can discuss.
Sir, can we have an example?
Yeah, definitely we'll go for example. Okay, but let us try to understand the formula first. Okay, once you are able to understand the formula, definitely you can solve the problem. Okay, so just try to understand the formula. Okay, if you have no doubt, definitely we are waiting for the examples. So do you have any doubt?
No, sir.
Okay, all of you got this chain rule formula for partial derivatives now?
Yes,
Yeah.
sir.
Yes, sir.
Okay, now let us go for the example. Okay, so once you are ready with the formula, we go for example. Okay, so let us try the example. let phi is a function of
Sir,
x, y, z. Yes.
so what are the practical applications of partial differentiation?
Very good. Okay. See, you're being a chemical engineer. Okay. So after you will go for second year and third year onwards. So in chemical engineering, we prepare a lot of chemicals. Okay. Um, Definitely we go for industrial applications of chemicals. But to understand the kinematics of chemical reactions, okay, we need to understand the partial differential equation or mathematical model of this chemical reaction gives you the partial differential equation. Okay, so the kinematics of the chemical reactions or the chemical plants, okay, they are modeled into the partial differential equations. And that's why understand that we need to understand first how this is going to happen, okay, or how to understand these models. That's why we are studying here partial derivatives. Okay, so if we go through the example, I'll recommend you the book to be referred. There is a book, Numerical Methods for Chemical Engineers, okay, by Atkinson. Okay, so the book starts with the partial differential equation itself. Okay, and that's why it becomes necessary to understand the partial derivatives. Okay, so we can go in more details with the help of examples and all. Okay, but here let us try to understand what is partial derivatives. So I hope up to some extent I have satisfied your query.
Yes, sir.
Okay, so you will come across these partial differential equations. Okay, right now we are in derivatives only. So whatever the derivatives we are making, that will become partial differential equations. And then as you have the ordinary differential equations, so these partial differential equations involve when you have more than one parts or more than one phenomena involved. Okay, so when we go for chemical reaction, there is not only one chemical involved in that reaction. There are many chemicals involved in the reaction, and then as there are many inputs, so there are also many outputs. Okay, and when we have many inputs and many outputs, and we have to relate this, so everybody involves partially. Okay, so when we consider a chemical reactions, so there are atoms and molecules. Okay, those get separated and get attached. Okay, and this depends on the concentration of the chemical. This depends on the solvent what you are using. This becomes where at what temperature you are doing that chemical reaction and all. Okay, so that's how the chemical plants they get their model better in partial differential equation. Okay, so that's why it is very important to understand this partial derivatives and partial differential equation. Okay, so here this phi is a function of x, y, and z, and I can say where x is equal to square root of b and w, y is equal to square root of u and w, and z is equal to square root of u and v. then find u double phi by double x plus v double phi by double v. Here it should be u double phi by double u, v double phi by double v, and plus w double phi by double w. Okay, so this is the question. Okay. Now, once we have the question, okay, and as you can see, phi is a function of x, y, z, x is a function of v and w, y is a function of v and w, and z is a function of u and v. And if we put this values here, phi will become the function of u, v, and w. Okay, so let us try to understand what is the variable tree. So we have phi, okay, then phi is a function of x, y, and z. Now, this x is a function, okay, of v and w. Y is a function of u and w, and z is a function of u and v. So you can see in x, u is missing, in y, v is missing, and in z, w is missing. Okay, but if you see, here we have v and w, here we have u and w, and here we have u and v. So ultimately, the set of variables is u, v, w. Okay, so first set of variables is x, y, z. That is, phi is a function of x, y, z. And again, this x, y, z are the functions of u, v, and w. Where in x we don't have u, where in y we don't have v, and where in z we don't have w. But overall, if I replace the value of x here and the value of y here and the value of z here, then I'll get the definition in terms of u, v, and w. Okay, so this phi is a function of x, y, z as well as u, v, and w. Now, we have to understand how to use the chain rule. So we want to find this term. So we want to find double phi by double u. We want to find double phi by double v. We have to find double phi by double w, and then multiply this three derivatives by u, v, w respectively. And after simplification, we have to add this. Okay, so this will be your equation 1. This will be your equation 2. And then this is going to be equation 3, and then we can add equation 1, 2, and 3, and then we'll get the solution or the term claim what we want to find out. Okay, so actually I can write it as true that, but I don't want to drag the answer, so I want to find the answer. We want to derive the answer. Okay, so what we'll be having, let phi is equal to phi of x, y, z. Okay, where x is going to be root of v, w, y is going to be root of 2w. Okay, and z is going to be root of uv. Okay, so is there any doubt in this variable tree? Do you have any doubt in variable tree?
No, sir.
No, sir.
Sir,
No,
but
sir.
what is the equation of phi?
Phi, the equation of phi is not given. So
Yeah.
whatever we can have. Okay, so phi may be x square, y cube, z z. Okay, whatever the definition of phi we have, but definitely it will be in terms of u, v, and w. As if we replace x, y, and z, so it will turn out in terms of u, v, and w. Okay.
Okay.
So now, if I have this variable tree, then we are able to find the formula for the derivative with respect to u, the derivative with respect to v, and the derivative with respect to w. Okay, so as we want to find the derivative with respect to u, v, and w. Okay, so here we have, okay, what we can have, W phi by W u. Okay, so we have to think where are the branches of u, okay, or where we are able to find the branches of u. So you can see here this is one branch and here is the other branch. Okay, so we have two branches. Okay, here u is not there, so derivative of x with respect to u will be 0. Okay, so we don't have to write this. Okay, so what we get here, here you can see W phi by W x and W x. This term is going to be 0. W x by W u is going to be 0. So, okay, so we skip this, and hence W phi by W y into W y by W u plus W phi by W z, and this is W z by W u. Okay, now similarly we can write W phi by W v is equal to W phi by W x and W x by W v plus W phi by W z, and this is W z by W v. Because v is not present in y, so we don't write y term, and hence what we can have the next, so we can write for w. Okay, so you can see for w, we'll be having here W phi by W w, and this is W phi by W x by W w plus W phi by W y and W y by W w. As in z and w is missing, so the derivative of z with respect to w is going to be 0, and that's why we don't have to write that term. Or if we can try to calculate, it is going to be 0. So let us avoid it. Now these are the derivatives that we have to find. Okay. So out of these derivatives which are possible. Okay. So out of these derivatives which are possible, W y by W u is possible, W z by W u is possible, W x by W v is possible, W z by W v is possible, W x by W w is possible, and W y by W w is also possible. So these are the 6 derivatives which are possible. Okay, and let us calculate this derivative. Okay, so we calculate the derivative of phi with respect to u and multiply it by u. We calculate the derivative of phi with respect to v and multiply it by v. We calculate the derivative of this phi with respect to w, and then we multiply it by w, and then we can add this. Okay, so to find these derivatives, we need to find these 6 derivatives first. Okay, so let us try to find these derivatives. So the derivative of x with respect to v and w, the derivative of y with respect to u and w, the derivative of z with respect to u and v. Now you can see all are the square roots. Yeah, so all are going to be the square roots. So when I'll find the derivative with respect to v, w is treated as a constant. When I'll find the derivative with respect to u, here w is going to be treated as a constant, and like that. Now, what is the derivative of root x?
1 upon
By
1 by 2 root x.
Yes, 1 upon 2 root x. So this is the simple formula that we are going to use here. Okay, and then it requires the simplification. So let us find the derivative, these 6 derivatives, and then we'll try to find out these derivatives. Okay, so what we can do is, we can write here, consider the derivative of x with respect to v. So can I write this as root of w upon 2 root v? Are you getting this? Are you getting the derivative of x with respect to v?
Yes, sir.
Okay, because here root of w is going to be constant. So root of v, we have to differentiate, and that is going to be 1 upon 2 root of v. Now, if I consider the derivative with respect to w, then v is going to be treated as a constant, and the root of derivative of root of w is 1 upon 2 root of w. Now, of y, so the derivative of y with respect to u. These are all going to be partial derivatives because x is a function of more than one variable, y is a function of more than one variable, and z is also a function of more than one variable. Okay, so whenever you have the function of more than one variable, that means you have to consider partial derivatives only. Okay, so here what we can have is root of w remains constant, and this is 2 root of u, and double y by double w. So this is what you'll be having. Root of u remains constant, and this is 2 root of w. Now the derivative of z, so double z by double u. So it is root of v upon 2 root of u. Okay. And what is the last remaining? So double z by double v. So it is root of u remains as it is, and this is 2 root of v. Okay, so have you got these 6 derivatives?
Yes, sir.
Have you got these 6 derivatives? We have differentiated this x, y, z with respect to u, v, and w.
Hello, sir.
Okay, and now
Yes, sir.
we have to put these values in this formula.
Hello, sir.
Okay, so let us consider one by one. Yes,
Sir, I want to ask one question.
yes,
You found out that double x upon double. So what is that double v, right, sir?
double
X upon double v
x upon double v.
means you find out the derivative of x with respect to v.
Yes,
So, sir, the formula is if it is root x, then it is 1 upon 2 root x, right, sir?
yes, yes,
So if we look at x is equal to root of u vw, so
yes,
sir, the derivative must be, sir, 1 upon 2 root of u vw into root of w, right, sir?
yes.
So why it is written as root of v only?
Okay, very good. Okay, so let us try to have the derivative of this. So double x by double v. This is double by double v of root of vw, right? Is that okay?
Yes, sir.
Okay, double by double v of root of v into root of w. Is that okay?
Yes, sir. Okay.
Good. Okay, so we are finding the derivative with respect to v. So can't we treat w as a constant? Can we treat w as a constant?
Yes, sir. We treat as constant.
Correct. So this is root of w double by double v of root of v. Is that okay?
Yeah, sir. Okay.
Okay. So it is root of w. What is the derivative of root v?
1 upon 2 root v.
Good. So this is 1 upon 2 root v. So can we write it as root of w upon 2 root of v?
Yes, sir. Yes, yes.
Got your idea clear?
Now it is clear. Thank you.
Good. Good. Okay, no problem. Okay, so this way we are able to do all the calculation. Good. Okay, so it's always better to have the doubts clear. Okay, good. So we got this 6 derivatives. Okay, and now let us try to calculate these derivatives one by one. Okay, so we have double phi by double u first. Okay. Now use this derivatives. So what we want double y by double u. Okay. So let us have this double y by double u. What is going to be double y by double u? So we can see here it is going to be root of w upon 2 root of u, and this is double phi by double y plus What is double z by double u? So it is root of b upon 2 root of u double phi by double z. Okay. So these values we have put. Now see the claim what we want. We want u into double phi by double u. Okay. And hence what we have here. So we write here multiplying above equation by u. We have. So what we got here? U double phi by double u is equal to u into root of w to root of u double phi by double y plus u into root of v on 2 root of u double phi by double z. Okay. Now we can cancel one root u. Okay, and we can have this is 1/2 root of uw double phi by double y plus 1/2 root of ub double phi by double z. Okay, but you can see what is u root of uw is going to be by, and what is root of ub is going to be z. So I can replace these terms here and I can write here u double phi by double u is equal to, this is y by 2 double phi by double y plus this is z by 2 double phi by double z, and let this equation. Okay, so this is going to be equation 1. Okay, now think of the derivative with respect to v. Okay, so we have double phi by double v. Okay, so what we have here, double phi by double v. See, we have to use double x by double v, and that's what the term here. We have to use double z by double v, and that's what the term here. So let us write these terms, and then we have root of w upon 2 root v double phi by double x plus root of u upon 2 root of v double phi by double z. Now multiply this by v. Okay. So multiplying above equation by v, we get. So it is going to be v double phi by double v, v into root of w by 2 root v double phi by double x plus v into root of u by 2 root v double phi by double z. Now we can write next. So we can have v double phi by double v is equal to, so it is root of vw by 2 double phi by double x plus root of uv by 2 and double phi by double z. But we can see this is x exactly and this is y exactly. So we can have v double phi by double v is equal to x by 2 double phi by double x plus this is z by 2 double phi by double z, and this is equation 2. So is there any doubt this equation 1 and 2?
No, sir.
Is there any doubt? All of you got up to equation 1 and equation 2?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's
Yes,
good.
sir.
That's good. Okay, so up to equation 2. Okay, the thing is clear that we got equation 2. Now, what we have to do is think of the derivative of phi with respect to w. Okay, so let us think. What we have here, we have the derivative of x with respect to w and the derivative of y with respect to w. So these two derivatives we can replace. Okay, so let us replace these two derivatives. Okay, then we have consider dabba phi by dabba w. So here we can replace the derivative of x. So that means it will be root of v upon 2 root of w dabba phi by dabba x. And we replace y. So it is going to be root of u upon 2 root of w and dabba phi by dabba y. Okay, so these are the values that we replace. Please check. Okay. Now, what we have to do, the next, we have to multiply this equation by w. Okay, so multiplying of equation by w, we have, okay, so what we'll have w dabba phi by dabba w. Okay, so w into dabba phi by dabba w is equal to w root of v upon 2 root of w dabba phi by dabba x plus w root of u upon 2 root of w and dabba phi by dabba y. So here we can cancel one root of w and then we can have this as root of v into w by 2 dabba phi by dabba x plus root of u into w by 2 and dabba phi by dabba y. Okay, so this term is exactly going to be x again and this term is going to be y. And once we have this x and y, we can replace and then we can write this w dabba phi by dabba w is equal to x by 2 dabba phi by dabba x plus y by 2. Okay, so we can have this is y by 2 dabba phi by dabba y, and this is going to be equation 3. Okay, so we got equation 1 for u, we got equation 2 for v, and we got equation 3 for w. Okay, so if you see what we want to find, okay, so there are three parts: the derivative of uv and the derivative of phi with respect to uv and w, and we have to multiply these derivatives by respective variables uv and w, and then if we add these three, then I have to find out what I'll get. Okay, so we have equation 1. Okay, so there's going to be equation 1. Okay, then we have equation 2. Okay, so we got here the second term, what we wanted to get. Okay, and then we have equation 3. Okay, so the claim that we want to calculate or the term that we want to calculate is nothing but the sum of all these three equations. So it is nothing but the sum of all these three equations. Okay, so let's have the sum of all these three equations. So we can say adding equations 1, 2, and 3. Okay, so we get what we are able to get here. C. So it will be u dabba phi by dabba u plus v dabba phi by dabba v plus w dabba phi by dabba w. So about u, what is u? U is y by 2 double phi by double y plus z by 2 double phi by double z. What about the second equation? Second equation is x by 2 double phi by double x plus z by 2 double phi by double z. And what is the third equation we have here? So it is plus x by 2 double phi by double x plus y by 2 double phi by double y. Okay, so these are the terms we have. Now you can see this y by 2 term and this y by 2 term. Okay, then you can have this z by 2 term and this z by 2 term. And we can have this is x by 2 term and this is x by 2 term. So if we combine this, what I am able to get is x by 2 plus x by 2. So it is going to be x. So it is going to be double phi by double x plus y double phi by double y and plus z double phi by double z. Okay, so what we got here, we got that u, okay, so it is u double phi by double u plus v double phi by double v plus w double phi by double w. This is x double phi by double x plus y double phi by double y plus z double phi by double z. So you can see the LHS that we wanted to calculate, and then we calculated and we got the RHS. Okay, so here our example is, and so here we got our example completed. Now, is there any doubt?
No, sir. No, sir.
Or is there any doubt?
No,
sir.
sir.
No, sir.
Okay, all of you got this.
Yes, sir.
Yes, sir.
And so here, the definition of function phi was not exactly given. Okay, but we were able to manage it. Okay, and that's why we got the derivative for the given function u, and then we got the claim also. Okay, so is that okay? Have you got this?
Yes,
sir.
sir.
So let us try to find another example, or let us try to have another example. Okay. Now here we'll try to find, suppose there is a function z which is given as I hope all of you are able to see this journal, right?
Yes, sir.
For the example, if z is equal to x log of x plus r and r square is equal to x square plus y square. Okay, so when you read the question, okay, you should able to understand what is the variable tree in this example. Okay, so now you can see, okay, what we have exactly. Okay, so here what we have, z is a function of x log x plus r. This is what we are able to see first. But the next line, we are able to see that r square is equal to x square plus y square. Okay, so that means r is again a function of x and y. And now we have to find the claim. Okay, so what is the claim we want here? Let's modify this. So it is going to be minus r, where r square is equal to x square plus y square. Then find double cube z by double x cube. Okay, so this is what we want to find. So we can see z, which is a function of x and r. So we can see here, it seems to be the function of x and r. But r is again function of x and y. So what we have, r is a function of x and y. And here, the definition of r is given, r square is equal to x square plus y square. So if you want to find the derivative of this z with respect to x, so we have to go for partial derivative. And here, what will be the derivative? So we'll be having double z by double x. So here we have double z by double r, and double r by double x, double r by double y. Again, so these are the derivatives you will have. Now, this is how you can see the variable tree for this problem. Okay. Now, once you are sure with the variable tree, so you can see we have to find the derivative of r with respect to x, and then the derivative of z with respect to r again. Okay. So we can directly find the derivative of this function with respect to x. So as we know, z is going to be the function of x and y. So we have to find the partial derivative. Okay, so let us try to find what is the derivative of this z of order 3 with respect to x. Okay, so let us try to find this derivative. Now, if you want to find the derivative, we have to find the derivative of r with respect to x also. Okay, and hence we go the solution. So what we have, like z is a function x log of x plus r minus r, where r square is equal to x square plus y square. And from this variable tree, if we want to find the derivative of this z, we need the derivative of r with respect to x. So I can write here differentiating equation, this equation. Okay, or we can write differentiating r square with respect to x partial we get. So what we are able to get here, so is it 2r double r by double x? Are you able to get this?
Yes, sir.
Yes.
sir.
And now on this side, see what we get, 2x only. Is that okay? Because we are
Yes.
differentiating partially, y is treated as a constant. So can I have r double r by double x is equal to x? So I can write double r by double x is equal to x by r. Is that okay?
Yes.
Yes, sir.
Getting this? Good. Okay, and now once I know the derivative of this r with respect to x, then I am able to differentiate this z with respect to x, because again here I need the derivative of r with respect to x, so that we have done already. And hence now differentiate this z with respect to x. Okay, so we write here differentiating z with respect to x partially we get. Okay, so what we are able to get is, see, dabba z by dabba x is equal to dabba by dabba x of x log of x plus r minus r. Okay. Now here we have to use u into v rule. This is okay. So the derivative of x is going to be 1. So it is going to be x plus r plus x remains as it is. The derivative of log is x plus r and dabba by dabba x of x plus r minus dabba by dabba x of r. Are you getting this term?
Yes, sir.
All of you are getting this term? Okay. So what we got here, this will be log of x plus r plus deriving x upon x plus r and the derivative of this term. So it is going to be 1 plus dabba r by dabba x minus dabba r by dabba x. Okay, so we got here, this is log of x plus r plus x upon x plus r. Okay, and this term 1 plus x by r, because you can see here the derivative of r with respect to x is x by r. So this is x by r and minus this is going to be x by r. Okay, don't be in hurry. That is the most important thing. Otherwise, you will cancel this x by r and this x by r. So don't be in hurry. Okay.
Sir,
Yes.
here r will not be considered as constant.
R is a function of x and y, no?
Okay, huh.
We are considering r is a function of x and y. So r is not a constant.
Yes, sir.
Okay. Correct. Okay. So this is equal to, we got here log of x plus r. Now see this term plus x upon x plus r. What this term will be? This will be r plus x by r minus x by r. Are you getting this term? This r is multiplied here. Is that okay? Are you getting this term?
Yes, sir.
Yes, sir, got it.
This term, the numerator and this denominator will get cancelled. Is that okay?
Yes,
This
sir.
is x plus r and this is r plus x. So they will get cancelled. Is that okay?
Yes, sir.
Yes.
Yes, sir.
Okay. So what is the next step? Log of x plus r plus. Now this x and this r will remain. So x by
upon
r and minus x by r. So now this will get cancelled. Okay. And so what we get is log of x plus r. So we got here dabba z by dabba x is equal to log of x plus r. Is that okay? Are you getting this?
Yes, sir, got it.
Now see what we want the third order derivative. So again we have to differentiate this with respect to x. Okay. So we write here differentiating above equation with respect to x partially. We get. So what we'll be having here hence dabba 2z by dabba x square is equal to. So dabba by dabba x of log of x plus r. That is 1 upon x plus r dabba by dabba x of x plus r. So we get here 1 upon x plus r into. This will be 1 plus dabba r by dabba x. So it is 1 upon x plus r and this term. So it is going to be 1 plus x by r. So we have here 1 plus x, 1 upon x plus r, and this is r plus x by r. So can we write this 1 by r?
Yes, sir.
Because this term and this term will get cancelled and we will be having only 1 by r. So what we got here, we got dabba square z by dabba x square is equal to 1 by r. Okay, and now once it is 1 by r, it is easy for us to differentiate. Okay, as we want the third order derivative, so again we go with differentiating above equation with respect to x partially we get. So what you are able to get here, see, so it is dabba cube z by dabba x cube is equal to dabba by dabba x of 1 by r. What is the derivative of 1 by x?
Minus 1 by x square.
So minus 1 by r square. But is it sufficient for this term?
No, sir.
No, dabba r by
by
dabba
dabba
x.
Correct. So r is being a function of x. We have to find its derivative. Okay. So it is going to be minus 1 upon r square. And this is dabba r by dabba x. So it is minus 1 upon r square. And this term is x by r. Okay. And so here we are able to get dabba cube z by dabba x cube is equal to minus x upon 2. And this is the final answer that we wanted to. This is what exactly we wanted to. And so here, so when you consider any example, first try to identify what is the variable tree. Okay, and once you get the variable tree, you know how to make the formula. Okay, so here again we have seen the variable tree, and once you know the variable tree, you are able to make the formula. So once you know the formula, then it remains to calculate the terms. Okay, and definitely we are able to calculate the term. We are easily able to calculate the derivatives. Okay, so the formula for derivatives remains as they are. Okay, so now, is there any doubt? If you have any doubt, you can ask. So is there any doubt?
No, sir.
No, sir.
So all of you got this all examples.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Very good. Yes. So will you be able to solve the problems based on partial derivatives now?
Yes, sir.
Yes, sir.
Yes.
That's good.